In this lecture, I'm going to discuss about some special case in minimization techniques, that is don't care conditions. So what first we'll see what is this don't care conditions. So up to now we have seen for all the given functions or Boolean functions, so those functions are called completely specified functions. So what is the meaning of this completely specified function is for all input combinations, right? For all min terms, we know the function value, right? So for this input combination, the function value is 0. Next input combination function value is 1. Next input combination function value is 1. The last combination is 0. That means we know the complete information about the Boolean function, or we can say the system. So that is why we can say this is completely specified function or completely specified system. Now how can I write the function value or a Boolean function? So we know that, so this is one min term, so I can write sum of min terms, that is a bar b plus ab bar. So these are the sum of min terms. Now I can write for the completely specified functions like this. Similarly for 3 variable, 4 variable, as well as 5 variable, and so on, right? So this is about the completely specified function. Suppose think that for these two input combinations or two input min terms, we know the function value. For the next two combinations, that is 10 and 11, we don't know, so that is incomplete. So we don't know, it may be 0, so this may be 0, this may be 1. Similarly, this may be 0, this may be 1. So we don't know completely. So that is, this type of functions are called incompletely specified function. So for this two input combination, the function value is not defined, right? It may be any value, right? So that is called this don't care conditions. These unspecified min terms of a function are called don't care conditions, right? So that is the don't care condition. So we don't know the function value for this input combinations. So example, if I take the BCD code, so I can represent 0 to 9 as BCD code. The unused codes will be there, no? From 10 to 15, so 10, 102, all ones, these are the unused codes in BCD code, right? Or we can say unspecified codes, right? So this is some example. So for this unspecified codes or unspecified functions, now how to minimize the expressions or how to get the expressions, that is the case we need to study, right? Now we'll see how to represent these don't care conditions in a truth table, or we can say Karnaugh map. Now we have to give a different name compared to either 0 or 1. So for this input combinations, so we don't have function value y. So what we assign is some different name, which is x, or we can say cross mark. So what is this meaning is, so we don't care about this two input combinations which will assign the function value. It may be 0, it may be 1. That is, we don't care, right? So that is x is equal to 0 or x is equal to 1. So depending on the situation, so we may assume this x is equal to 1, this x is equal to 0. So anyway, that we'll see in the example, right? So what is the don't care is, we can generally in some textbooks they will use small d also. See, don't care means either x, or some textbooks they will follow d also. In place of this don't care, they will follow some d. So d stands for don't care. So what is this meaning? So for these combinations, so input combination, the function value is either 0 or 1. That is, we don't care about that one, right? Next we'll see, if there is a don't care presence in the either truth table or map, now how to minimize the functions, that we need to see. Suppose something like this, some example is I have taken like this, or the XOR gate I have taken. Now for these two input combinations, I know the function value, and for these two input combination, I don't know the function value. Now when I try to minimize these functions, so what we need to assume this x value. So depending on our situation, suppose if this is only 1, if I assume, I will get two literals. See, 1 means this is only one min term it will represent. So what is this min term? 0, 1. So how to represent a bar b? So I will get two literals. So I need two input AND gate or something, two input gates. Now suppose if I assume this x is equal to 1, can I make a pair like this? Yes, I will make a pair like this. So what is this f is equal to? So one total column is filled, simply this is 1. How to represent 1? This is p. Now we may think that, so why we don't assume this x is equal to also 1? If I assume this x is equal to 1, I have to make a pair like this, so which will give extra literal. so which is we get some extra expression or extra gate also, right? So if it is a 2 variable, so that's why we'll get only 1 gate, but if I go to the 3 variables, so we may get extra term. So I told already, so x is it is a don't care condition. So the what is the functional value we assume is that is a undefined, or so it's not necessary, right? So in those cases, so I will assume only x is equal to 1, so I will eliminate like this. So I will assume in this case x is equal to 0, so because I will get extra term, right? Now this is f is equal to b. Suppose if I assume this is x is equal to 1 and this is also x is equal to 1, so what is the y? You will get b plus a. Yes or no? So it is containing 2 literals and it is containing 1 literal. So which one is the simplified expression? This one. So in this case, I will assume only x is equal to 1. This is x is equal to 0. So here, this is not possible. This one is, we should not take like this, right? So that is, what is the conclusion is, don't combine only don't care conditions, only don't care conditions, right, which will give extra terms and means, so we will not get simplified version. Now similarly, if I see the 3 variable, so these 2 ones are there and the 3 ones are there, 3 don't cares. Now what is the simplest possible combination here is, suppose if I assume these 2 don't cares also 1, so I will make a quad like this, right? If I make a quad, so I will get only 1 literal. See, so total this a is changing, so a is eliminated. So from these two, first one is fixed. So B, 0 means I will get b bar, only 1 literal. Now again, if there is a 1, if I assume this x is equal to 1 also, so this is 1 1 and this is also 1 1. So I can make a pair, but quad is better than the pair. So what I do, I will make a quad like this. So if I make quad like this, so what is the function value? 0 0 1 0. So c bar. So b bar plus c bar. Now see, we will get only 2 literals, right? Now if I see this example, now how to do it, this one. Now this is a 1 and this is don't care. So if I assume this don't care is as a 1 and this don't care is as a 1, I will make a quad like this. So what is the function value? Simply, so 0 0 1 0. So c is fixed, so c bar. Only 1 letter I will get. And if I think this don't care also as 1, then I have to make a quad like this, so which will give 1 more extra terms, which is not required at all. Yes or no? So this is the simplified one, right? So only we have to assume this x is equal to 1 when we are getting some simplified version. So that is the conclusion. See, when simplifying the function, we can choose to include each don't care min term with either the ones or zeros, depending on which combination gives the simplest expression. So which combination will give the simplest expression, then only we will assume this x is equal to 1 or 0. Now see, in this case, if I assume these two are also x is equal to 1, so I will make one more quad, which is not required, or which will give 1 more extra term, right? So in those cases, these two x is equal to 0. So whenever there is x is equal to 0, so I cannot make any combination, right? So that is about this don't care. So don't combine only don't cares, or don't combine so to get extra term, right? So always see that we'll get simplified version. In those cases, we'll assume this x is equal to 1, right? Now we'll see some more examples to get more clarification. So suppose truth table is given and the values, function values are given like this. So how to make or how to simplify the Boolean expression? Now 000 means 0, then 001 1, 0010 means 1, 011 0, 100 is a don't care, 101 is also don't care, and 1110 is 0. This is the 1. Now whenever this is a came up like this, so how to make? Now if you see with the 1, so I don't have any either pair or quad, so this is a single min term I will get. So function value is equal to, the single min term is nothing but a bar b c bar, plus if I see this one, I can make a pair if I assume this x is equal to 1. So in that case, I will assume this x is equal to 1. So I will get b bar c, plus now in this case 1 is there. So if I assume this x is equal to 1, so I can make a pair like this to get only 2 literal. So this literal is a, so this row a, and in this 2 c is common, so ac. So this is the simplified expression. So only one x is sufficient to get some simplified one. So if you assume this x is equal to also 1, so one more term we will get, so which is not useful, or which we can say redundant also, right? In those cases this x will be 0. Now we'll say 4 variable. So in these cases how to make, see, if you see there are 2 or 4 ones, I can make a quad like this. But if you see this corner, all are don't cares. So if I assume this all are don't cares are x is equal to 1, so I can make a octet here, right? So this is octet, right? So adjacent square. So what is the function value? So which one is common? 0 0 1 0. So d bar is common, so d bar plus, and if you see this one, so if I make a quad like this, because in this case x is equal to 1, so I can make a quad like this. So what is this? 0 1. So simply a bar b, because total row is filled. Next, see, these two are remaining, so what I can make one more quad. So don't make a pair, because it will give 3 literals. So always try to go for the bigger one. So either octet or quad. Then if it is not possible quad, then go for the pair. So what about this one? A b bar, a b bar. This is how we have to perform. Now one more example we will see. So in the exam, or in the generally we say function value will be given like this. So don't care also will be given like this. So in these positions we have to place don't care. In these positions we have to place 1. So at position 1 or min term 1, so 1, then 3 also 1, then 7 also 1, then 11. So 8 9 10 11, here 1, then 15, here 1. Then don't cares where 0. So at here don't care, then 2, don't care, then 5. Where is the 5? 5 here. The remaining positions are 0. Now how to make combinations? See, always try to see we use less number of don't cares, right? Now how to make, see, all ones are there, so I can make a quad like this, simple. And if I assume this one, if you see, I can make a quad like this if I assume this x and this x is also 1. So I can make a quad like this. So to simplify, only how much? So the entire column is filled, so this is simply CD, and this totally filled, so simply A bar B bar, right? So whenever there is a quad is possible, then go for how many more number of don't cares, no problem. Even single one is there, if it is possible to get a quad, then go for that one, because it will give simplified expression, right? Next we will see one more example. So we'll see the last one with a 5 variable k-map. So f of abcd is given like this, and don't cares are given in this position. So I have given the numbers directly. So in these positions I will give, in these positions we have to represent 1. So 1 means here, so 1, then 3, then 5, 7. See, 1 3 5 7, then 9 is here, then 21. So where is the 21? 21 here, then 25 29 31. So 25 here, 29 here, 31 here, right? So what are the don't care positions? 4 6 10. So 4 6, this is here 10, then 15, then 17 19 23, 17 19, then 23. The remaining positions are zeros, so all are 0 zeros, 0 0 0 0. Now how to combine? Now see, if you observe, this total column is filled, and this only up to 3 is filled, right? Now can I make any octet from this to this? So just think, this is on top of this one. Now is there any adjacency is happening? See, this column is filled, so there is no octet is possible, because these two are adjacent. So if this is a 1, I can make a octet. But if you see these four ones and these 4, see, if I assume these 3 don't cares are 1, so I can make something like this 4 and this 4, I can make an octet, right? Something like so, just mapping, right? So if I place this 4 variable came up on top of this one. So these 4 and these 4 will become octet, right? So I'll make like this. So this will represent what is the equivalent? See, in this 2, A is changing, so 0 to 1, so A is eliminated. And in these 2 rows, which one is common? First one, B bar. So this represented B bar. Then here also B bar. Here 0, 1, 1, 1. So E is fixed. So B bar E. So this octet represented by B bar E. Now, is there any octet is possible? Okay. So only one here, only one is left here, and here see 3 left. So what I can make here is, see, simply I can make a quad like this. Yes or no? Then only one is left. So this one is left. So what I do? I will make a pair like this, right? These two. Because if I make a pair like this, again I have to make one more pair, so which will become redundant, right? We have to cover all ones with less number of terms. So that is less number of either quads or pairs. That is the reason. So if I make a pair like this, so no need of again one more pair, so which will become redundant, right? So that is the reason I am making a pair like this. Now I will write a function value. So function value is equal to, I have made a octet like this, which was B bar E. Next, which was a quad. So here quad is there. So for this quad, which will represent as A. So first I will represent A. Then in this 2, which one is common? The second one, which is represented by simply C. And in this 2, which one is common? The second one, which is E. A, C, E. Plus only one pair is there. So this is the pair. So in these 2 pairs, A is changing. So A is eliminated. So what is this row? See here. What is this one? 1, 0. So how to represent 1, 0? B into C bar. Now here, this column represented by 0, 1. So how to represent 0, 1? B bar E. So this is the simplified expression. See, 1 octet. So 4 ones are covered. Here, 1 is covered. Then to cover these 2, I made a quad like this. So only remaining is this one and this one. So I made a pair. So this will give the simplified expression, right? So this is how to use these don't cares and simplify the expressions, right?